edge designations, CFA Level 1, pre-reading, quantitative methods, learning module 5. This is the 5th module out of 6 for quantitative methods, sampling and estimation. As per usual, what we do on every front page of our notes is we give you the learning outcome statements, okay, just to make sure that everything that is required to be covered, of course, does get covered. And this particular learning module 5, is really a start and a continuation, okay, both a start for the next learning module, hypothesis testing, and really a continuation of what we saw in the previous few modules, of course, starting off with learning module 3, which was probabilities. We'll talk a little bit about estimators, okay, confidence intervals and point estimates. Keep in mind we spoke about that in learning module 4, and we carry on with things like that. Let's get started straight away, hop straight into learning module number 5. Here we go. And as per usual, guys, we always show you the learning outcome statements again on each and every page, just to make sure that we cover everything that is required. Identify and describe the properties of an estimator. Now, just before we get going on this particular reading, we just need to just make sure we are fully familiar with what we are dealing with. Now, if we look over here, okay, sampling and estimation. Now, you've got to ask yourself the question, just as we get going over here, why am I sampling anything and why am I estimating anything? Why don't I have exact answers? Now, remember, going right back to the beginning of where we started on learning module 2, okay, where we showed you big N and little n. Big N is equal to the population. Remember, we described big N as population, and we called all the measurements coming out of that of a population, we call those parameters, population parameters. So, for example, if you have a mean and a variance and all the kind of good measures, okay, and they relate to a population, we would call those parameters. Little n is called a sample, okay, and from samples, the measures that come out of a sample, the mean, the variance, things like that, those are called statistics. Okay, so I can't give you an exact percentage, but a large amount of time we are not working with the whole population. And the reason for that is often it's very difficult to get to work with the whole population due to its size. Okay, if I just say to you, do me a favor, can you do a specific test on, for example, a margarine? Now, how would you do a test on a margarine? Let's say you want to do a test, for example, the fat content in a certain margarine. Well, the best way would be to go and get every single bit of this margarine that's ever been sold. But now, keep in mind, that's a very difficult ask, a very difficult job, because where would you get them? You have to go to every single store, every single country that these were ever sold. Okay, so what we do is we just take a sample then of the margarines, or the sample of whatever the greater population, and remember, of course, make that sample representative, but remember, it is just a sample. And because it's just a sample, there's a fair measure of what we call estimation. We start off over here on page 2, and we say describe some of the desirable properties of an estimate. If I'm going to use something to be as my estimator, what do I want my estimator to be? Unbiased, okay, which is the most desirable property for the estimator, okay. In other words, what does it mean if it's unbiased? If the mean, the average of my particular estimator, gets as close as possible to the actual population number. So the mean of my sample and the mean of my population are very close. It's efficient. In other words, there's no other estimator of this particular parameter, okay, that's got a smaller variance, a small amount of dispersion than what I'm currently using at the moment. And it's consistent. In other words, as we increase the sample size, the accuracy goes up. And remember that that's of course what happens. As we increase the sample size, the larger we make our sample, all the way, if we keep on adding to my sample size, till I get to a sample size that is in fact the entire population. That's perfectly accurate, isn't it? Okay, so what we've got over here, guys, is we've got our various what we call the properties of estimator, unbiased, efficient, and consistent. Okay, and what we know so far is that X bar, okay, is an unbiased estimator for the population mean. Population mean is denoted by the mu. Everybody comfortable with that? Okay, and we'll talk about more about unbiased estimators as we go through. Okay, we start on to page number 3, and it says contrast a point estimate and a confidence interval. Okay, now remember again, we are working with a sample. We'll look at a nice example. We saw this, guys, remember, in learning module 4. It does come up here again. And if you have a look over here, it says contrast a point estimate and a confidence interval. Remember again, guys, I'm working with a sample. So yes, once I've done all my numbers on the sample, what do I come out with? X bar. My X bar is my mean. But remember, it's the mean of the sample. Okay, that's also equal to what we call the point estimate. That's my starting point. Now the big question is, if I run my numbers and I come up with a point estimate or a mean of the particular sample, why can't I stop there? Let's say, for example, I'm trying to measure the fat content in a margarine. Okay, and we run a sample, and I get the mean, and I say there are 5 grams of fat in the margarine. Is everybody comfortable with that? Based upon my sample. Why can't I stop there and just conclude with that? Well, remember, because it's a sample. So we say, well, that's my starting point. That's my X bar. That's my mean. That's my point estimate. That's my starting point. We make certain adjustments based upon what we call the confidence interval. We saw this in learning module 4 to say, well, yeah, there may well be 5 grams of fat, but we're going to work within a certain range just to make sure that we can say, well, we know we're not exactly sure of the answer. The reason I'm not exactly sure of the answer is because I didn't work with an entire population, but yeah, it's fairly close. Okay, and we give ourselves a little bit of a range. We'll show you that in a second. Okay, good. And if we look over here, okay, what I'm going to do over here, we're going to do this more by way of example. It's a lot easier. And remember, guys, again, we've seen this before. Remember these, we saw this in learning module 4, okay, that, and I'll just draw you the picture quick. Remember when I've got my normal distribution? Maybe that's a little bit peaked, I don't know. And there is my middle point. Remember my middle point over there. The middle point is the mean, the middle. And we say, if I'm working over there and I move 1.645 standard deviations minus to the left and plus 1.645 standard deviations to the right, to the positive, in other words, I'm sitting right about there. What percent of the observations have I got? 90%. I'm just missing the last little bits on the tails, I suppose, haven't I? Okay, everyone comfortable with that? If I wanted to gain a little bit more and go 95% all of observations, I've got to move a little bit more to the right and to the left. How much more? 1.96 standard deviations. If I wanted to include 90% of all observations, sorry, 99% of all observations, I would have to go 2.576 standard deviations to the left and to the right, to the left and the right of what? Of the mean, of the average, the middle point. Okay. Let's go over here a little bit. Let's look at an example over here. Okay, and I'm going to do this whole example with you from start to finish. I'm even going to go and see if we can't go and look at a table. Let's start to get involved in working with a table. And just in case you were wondering, and you say, but hold on a second, are there 6 or are there really 7 learning modules for the pre-readings for Quants? What you'll notice is that the 7th reading, or the 7th learning module for Quants, is in fact the Quants tables, which we'll be working on today. So not effectively a learning set of material, but in fact a set of tables, which I'm going to start to work with a little bit today. Okay, we start off and focus very carefully on what we've got. Confidence intervals, and both, and look over here, 2 things are known. Number 1, we know the mean of the population, and I know the standard deviation as well. Now the minute we know both of those, guys, remember from learning module 4, we can use the Z table. Everybody comfortable with that? Okay, the minute this one's not known, the standard deviation is not known, remember we spoke about that previously, then we've got to go and use the T table, which uses degrees of freedom. We saw that all in learning module 4. Okay, let's go over here. Let's get every bit of information that I can from my particular table, from my particular question. The mass of water in a swimming pool at a randomly chosen time with a normal distribution, and when you see a normal distribution, you breathe a sigh of relief, because then we can work with all our normal principles that cover that of a normal distribution. It's got a variance of 1.44 tons. So straight away, guys, what I suggest is the minute you see the word variance, just do your conversion straight away. And remember, how do we go from variance? Because we always need standard deviation, our calculations. Always go 1.44 and just root the 1.44. And I'm going to get, so that I go from variance to standard deviation, which is now equal to 1.2. Everyone comfortable with that little bit of a, do that quite quickly, and then you free from that. My sample size, 9 randomly selected days. The mean mass of the water was 49.6 tons. And then it says calculate, okay, what is the mean mass of water in the pool? You say, but hold on a second, didn't I just calculate? I used 9 selected days to calculate the mean mass of water in the pool, and I've got an answer already. I've got 49.6. Remember what we do is, well, that was based on a sample of, well, yeah, 9 days. What I need to do is say, well, because it's not the whole population, I'm working with a sample, I better go and work with confidence intervals. And when I work with confidence intervals, what I do, guys, I work within a certain range. So I say, well, no, it's not. Here's my answer, my starting point, my point estimate is 49.6, but I'm going to work now within a range. Why? Because it was a sample, not a population. Let's have a look over here. And let's go for the 95% confidence interval. Okay. Look at your calculations, guys. It's always going to be the point estimate, and I'm going to use colors over here. Where did I get that from? There's my 49.6. Plus or minus 1.96. If I take you back, where's my 1.96? I'm working with 95%. If I just clean that up a bit. Okay. There is my 95% of all observations fall within 1.96 standard deviations. So everyone happy while I'm using 1.96. What I also want to do, guys, I want to show you where you find that. If you didn't want to learn those 3 different amounts, guys, off by heart, and you wanted to perhaps use a table, I'm going to show you then how to use the table, the Z table, how you find that 1.96 on the Z table. Okay, then we say times 1.2. Now where's the 1.2 from? 1.2 is my standard deviation. Okay, divided by the root of the sample size. There's the 9 over there. What you notice over here, guys, it's a little bit different to what you saw in learning module 4. That was really a starting point, and the only difference over here, guys, is now what I'm doing is I'm going point estimate. That's exactly the same as what you saw. I'm trying to make it clear for everybody. Plus or minus my factor, call it whatever you like, the Z factor 1.96. That was also the same. And previously, what did you see? You saw factor times by standard deviation. But what we're doing over here, and which is more correct, is we're going standard deviation over the root of the sample size. That little bit is extra. If you've given that in the question, please make use of that in your calculations. Okay, can everybody see where every single number comes from? Look what it does to me. It says, well, okay, my initial number was 49.6. Is everybody comfortable with that? That's from over there. Okay, that was my mean from when I took my sample. But now I go plus or minus a certain number. Okay, plus or minus what? Well, it's all of this in the bracket, isn't it? So 1.96, which is my factor, times standard deviation times the root of the sample size of 9. What does it now tell me? It says to me, and just focus very heavily here on how the words that we use. What are we going to say? We're going to say, well, hold on. I'm working with a 95% confidence level. So there's a 95% confidence level that the ranges for my mean, for my average mean mass of water in the pool is 48.8 to 50.38. And of course, guys, you can see that sits in between. Okay, my number that I did in my sample of 49.6 will sit in between those numbers, because yes, of course, on the one side I go minus, the other side I go plus, and I'm working within a range. Why again am I working within a range, guys? We know this by now. I'm working within a range, of course, because, okay, I'm working with a sample, not a whole population. Okay, so I've got to, now, what if we just move down one stage over here, if I want to be 99% confident, okay, if I want to be 99% confident, now I want to be even more sure that my number is correct, then what's going to happen, guys, is that my range of numbers, here my range of numbers goes from 48.8 to 50.3. If you want me to be more sure, well, then hold on a second, I'm going to have to increase my range. And you can see now we go from what, guys? At 99% confidence, I go from 48.5 to 50.6. In other words, my range of numbers has expanded, has widened, because you want me to be more sure. If you want more accuracy from me, you want me to be more sure, you want me to be 99% sure, not only 95, well, then I'm going to have to give you a bit of a bigger range. I can't tell you exactly within a narrow range. I'll widen my range, and I can be a little bit more exact to 99% for you. Is everybody comfortable with that? What I want to do over here, okay, is let us pop across now to and just to remember over here, guys, okay, what have we said? I'm just going to clean all of this up with one big nice clean. There we go. Looks like a new set of notes. Okay, and what do we know? Well, what did we say? We said that we start off with a 95% confidence level, has got a factor of what? 1.96. Where do you get that 1.96 from? Where does it come from? Well, we're going to go and look on our Z table for 1.96. Let us go to the Z table over there. Okay, now we've got our Z table, and remember, okay, and just have a look how you know you're working with the Z table. Cumulative probabilities for a standard normal distribution, we're happy with that, and there is my Z's. Okay, and now we're going to say to ourselves, okay, what am I looking for? Okay, ask yourself what you're looking for. Okay, and what I want to show you here is something that will hopefully help you throughout your particular studies. Okay, because if we have a quick look, and I'm going to show you why you might be wrong over here. If you're looking for what, guys, remember, what are we looking for? We're looking for let me write it out over here, 95% confidence level. Okay, so we go and look over here, just something to remember. Okay, and we're going to see this much more in the very next reading of hypothesis testing. But everything sums to 1. So if you've got a 95% confidence level, you have then got what, guys? A 5% level of significance. Okay, keep that in mind. Keep that in mind. I'm going to come straight back to that in a second. But if I look over here for a 95% confidence level, we look, and we say, okay, let's look over. Remember, you're looking here, guys. And if I can make this just a tad bigger, okay. Oh, there we go. Okay, now we say, okay, hold on. And by the way, this is what they're calling, okay, learning module 7. It's just really the CFA tables, Quants tables. So there's 87%, 88%, 92. I'm looking for 95, remember. Okay, so let's go and see if we can't find 95. Well, there's 94.95, there's 95. Everyone comfortable? Now if I had to go and read off the tables, what would you tell me? Well, let's read off the tables. Like on the left-hand side is 1.6, and on the top, 1.65, something like that. Okay, so per my Z's table, it's equal to 1.65. But what did we say? No. We were looking for 1.96. Remember that? Okay, so why am I getting 1.65 and I'm really looking for 1.96? And I can tell you that's the right answer, that's the wrong answer. But hold on a second, we're looking at 95%. Why is that wrong? Now we come to our principles. Okay, I want to take us down over here and just show you something very, very important. Okay, let's go again. I've got a confidence level of 95%. Then therefore I've got a level of significance of 5%. The first question you've always got to ask yourself, guys, in any of these particular questions is, am I dealing with only a one-sided distribution, one side of the distribution, one tail? There's my normal distribution. That is the left tail, that is the right tail, there is the mean. Most cases I'm dealing with how many tails? Two tails, both sides. The left side over there and the right tail over there. Okay, if I'm dealing with two tails, guys, now look what happens. Okay, if I'm dealing with two tails, now look what happens. Okay, we're always going to say, okay, hold on a second. Okay, if I'm dealing with two tails, I now need to take this level of significance, which is 5%. You happy? And do what with it? Divide it into 2.5% for who? For the left tail, and 2.5% for the right tail. Okay, everybody comfortable? Okay, so now what I've got to do is I've got to say, hold on a second, am I really looking at a confidence level of 95? It would be 95 if everything sat only in the one tail, but now I've got to put half into each tail. Look what we do. Okay, you've got to get this right, guys. We've got to go 95%. I've got to add on another 2.5% for each tail. So really what I'm looking for is a 97.5. In other words, when I'm now going to read off my table, what am I going to read off, guys? I'm going to read off 97.5. Why? Because I take my level of significance of 5, I've got to divide half into each tail. Okay, so what am I really looking for on the table, guys? It almost appears that I'm looking for 95%, but I'm not. I'm looking for 97. I would be looking for 95 if it was only one tail, but because it's two tails, I'm looking for 97.5. Let's go look over here for 97.5, see if we can find that. I'm going to change my color. Let's see, where's 97.5%? There we go. Everybody comfortable. And at 97.5, what have we got? Let's read off the table. 1.96. Okay, that's how, by the way, that's how you read off the table. You go to the left hand side, 1.9, and on the top 1.96. Can everyone see that's why in this particular case, yes, it's 95% confidence level. You may well think, okay, well, let me go and work over here at the 95%. Let me just clean up over there. You may say, well, let me go and work then at the 95% level, which sits round about over there. Okay, anywhere between these two is not an exact number. You may say, okay, let me read off here 1.65, 1.645. No, that would only be if what, guys? If it was one tail. Two tails, I've got to divide the level of significance in half, and therefore, can everyone see why, guys? I am using then, okay, this particular thing of 97.5. Okay, let's go back to our set of notes over here, and now hopefully everyone's got a little bit more clarity as to where we got the 1.96 from. Remember, guys, if you so choose, you're more than welcome to learn those off by heart. I don't, which is a fair thing to do. One can do that. Okay. On the other side, if you would like, of course, guys, you are also able to read them directly off the table, like I've shown you there. Be very, very careful, very, very specific. Is it two tails or one tail? Okay, and it's a little, I've written a little bit in the notes over there. You can read over that. We will handle that in much more detail again, guys, because you're probably thinking to yourself, well, hold on. One tail, two tails, how do we know? I'm going to show you that much more in Learning Module 6 when we start with hypothesis testing. Okay. we move on a little bit over there. Okay, now what I want to do, we're on to page number 5. Okay, look how my question changes. My question now says I want the confidence interval when those were known. Okay, we dealt with all of that already. A little bit of repetition, of course, but I just wanted to show you exactly how it works. Okay, normal distribution and the known variance. And that's, by the way, guys, that's just carbon copy of what we've seen already. I just put it in for you. We now need to see, guys, what about an unknown population variance? In this particular example, guys, the mean is known, the variance is known. What about if the variance was not known? Okay, we're going to go over here on page 6. Everything there up until there, guys, you've seen one time already. Okay, let's go, and I'm going to skip straight down to do an example together with you. Only one thing to tell you, guys, okay, that the minute you have got confidence intervals for where you know the mean, but you don't know the variance for the population, I move from Z's to T, the T table. That's all that changes. Okay, so if anyone says, well, when would you use Z, when would you use T? Well, I'm going to use Z when I know the mean and I know the variance. When would I use T? When I know the mean but I don't know the variance. Okay, and we'll just do an example of that together with you. Again, I want to show you then how to use the T tables. We've shown you a little bit of how to use a brief introduction, a brief look into the Z tables. We are now going to have a little bit of a look then also then into the T tables now. That's my example, and look at my example, guys. Okay, confidence intervals for we know the mean, but the variance then is unknown. Okay, and I've used exactly the same example. The massive water in a swimming pool, 9 randomly selected days. The mean was that, the variance is that. Okay, that's the variance that I've calculated, but I didn't know the variance for the whole population. And it says go 95, 99. Okay, exactly the same question as we saw before. The only difference in this question is that we don't know the variance. Okay, because I don't know the variance, guys, what I need to do, okay, I need to go and say to myself, okay, I'm now going to use T table. What changes with the T table? T table always says, okay, we go n minus 1. So what's my, okay, here's my sample size, 9 minus 1. Okay, so when I now go and look at the T table, I'm looking for degrees of freedom. That's how we read it off. I'll show you that in a second. Degrees of freedom of 8, not 9. Just remember that, guys. For the T table, we always go n minus 1. Okay, and let's go and have a look at, I'm going to do the first one over here. Okay, we're going to look at the T table, but before I look at the T table, guys, I just want to show you how we do the confidence levels, and you'll tell me, but isn't that exactly what we've done in the past? Carbon copy. What do we start off with over here, guys? We start off over there with what? The point estimate. Everyone happy? No changes so far. Plus or minus. This used to be, remember what? 1.96 when I used my Z table. Now what is it? 2.306. Why? Because I'm using a T table, but I'm still going to show you where you got that from. Then the rest is all the same, times 1.2. That 1.2 is what, guys? That is your standard deviation, and that is the standard error, or the root of the n. Everybody comfortable? So nothing changes in this example, guys, nothing at all, other than what? Because I don't know the variance of the whole population, I've got to use a T table instead of a Z. That's all. Let's go and see. We are busy dealing with a 95% confidence level. Let's go and look at the T table. Okay, we move along over there. Okay, just here we go. Oops, let's see if I can't turn this one around for you. Okay, let's just see if we can't flip this around. I'm going to try that for you. Did that work? I think I just set it the wrong way, perhaps. Let's try that one more time. No, that's exactly not what I want to be doing. See if I can't get it right for you. It works, otherwise we'll have to work with it as is. Okay, my apologies. Okay, doesn't matter, we have to work a little bit upside down, but as long as you can see what I'm doing, we're going to get the message across. Let's have a look over here. Okay, and remember guys, if you, on your kind of like imagine if this was the right way around, I do apologize, my system just seemed to be giving me a bit of a hassle over here, but let's just assume that it was the right way around, and remember, there we are dealing with degrees of freedom. Okay, and remember what we said, our sample size, let's just write that out for you. Remember that my sample, my little n, was equal to 9. Remember, we go 9 minus 1. I'm going to be working on 8. Is everybody comfortable? And then what did we say? Same story, guys. Nothing changes. Okay. Remember, what do we say? Well, I want a 95% confidence. But remember, guys, that there are two tails over here. So what do we have to say? There's 2.5% goes into the one tail, and then 2.5% goes into the other tail. So when I'm looking over here, guys, on the top of my table, I'll be looking there at 2.5%, not 5%. You might think, well, let's go here 5% because it's 95% confidence level. The other side of that will be the 5. No, we look at the 2.5. Why? Because there are two tails. I run my numbers across and we go there. Everybody see that? There's my 2.306. Okay, everyone comfortable with that? And that's where I get it from. And just again, just to recap again, guys, my sample size was 9. For my degrees of freedom, left hand side I always go minus 1. That's why I'm working there with 8. That's why I work over there. When I'm working with my confidence level, it's 95%, but it's two tails, so I take 2.5% in each tail, and that's why I work in that column there on the top, and that's how I get my 2.306, and that's obviously that number over there. And exactly the same then as I did before, guys, no change whatsoever. Okay, is that I'm working in a range then of, okay, my point estimate, my starting point was 49.6, but remember, I work within a certain range because I'm working with a sample and I don't have the full population details. So if you had to conclude, what would I conclude? 95% confidence that the range will be between 48.6 and 50.5 for my particular numbers. And again, you see later on over here, guys, we just, all that we do in the next particular thing is we go to 99% confidence, and look what happens to my my factor. It goes from 2.306 to 3.35. It's exactly the same as what happens then with a Z factor, guys, is that, okay, it gets quite a lot wider. The more sure I want to become, the more certain I want to become. I'm going from 95% sure, now I want to be 99% sure confidence level. Okay, then what I have to do, guys, I've got to widen my my interval gets a little bit wider. Everyone comfortable? So you can see it went from what? 48.6 to 48.2, all the way to 50.9 from 50.5. The interval itself got a little bit wider because I wanted to be a little bit more sure. Okay, so hopefully, guys, at this particular point in time, you guys are a little bit more comfortable when we talk now about sampling and estimation. Why do we sample? We sample because we can't work with the whole population. Then I use estimation. The minute I'm working with estimation, guys, be very sure that what I start to work with, guys, we start to work with either Z tables or T tables, and I work with what we call a confidence interval, a bit of a space that I work with to say I don't have the exact answer for you, but I'm going to give you an answer within a certain range. Okay, there we go. I'm not going to spend too much more time over there. Okay, okay, over our page over here, top of page 9, just a few little issues that we have when we're working with samples and things like that. Okay, we talk about, okay, data snooping and data mining bias. Okay. What is data snooping bias? Snooping is exactly what it is. You look into other people's business. Okay. So data snooping bias, the researcher uses results of others that have already done the job, okay, to guide his or her own analysis, as opposed to developing sound theories themselves. Okay, everyone comfortable with that? We move down over here to data mining bias. What's data mining bias? Data mining bias is exactly, look at the words, guys. I'm mining the data. I'm digging and digging and digging and digging, and we'll find something. Okay. In other words, this constant process of drilling through the data might will come up with some kind of a pattern, but we've always got to ask ourselves the question, okay, is there something in the pattern? Okay, or have we just discovered something by mining and mining and mining, and we've now found an answer? I'm not sure who came up with this particular quote, but there's a lovely quote that says, if you torture the data long enough, it will confess. Okay, it's going to give you some kind of a pattern, but is that pattern something that you were really looking for, or is it just a nonsensical, useless pattern? Okay, we look over here, a little bit over here, sample, some more biases, sample selection bias, survivorship bias, look ahead bias, and time period bias. Okay, sample selection bias, top of page 10, okay, is when you select your sample and you include and perhaps exclude certain data from the analysis, okay, is now you ask yourself the question, is it a valid sample, and is the sample truly representative of the population? Okay. Survivorship bias. Now, survivorship bias is a very interesting one. It's going to come up continually, guys, through your CFA careers. Survivorship bias says to you, hold on a second. When I look at data today, what am I looking at? I'm looking at the survivors, aren't I? Because remember, some stuff, let's just say, for example, if I'm looking at some investment funds. Now, what happens if I had an investment? Look over here. Let's just put onto a bit of a picture for you there. Okay. Let's just say, for example, time period 0, when all my let's say I started off with 5 funds in my company. I'm seeing at time period 5, and 3 of those funds are still around. Over here, one of the funds died, and another fund died over there. Why did they die? Because they were so terrible. Everyone comfortable? Okay. Now, when I come to measure my data, where am I measuring my data from? From here. I'm in time period 5, and I'm using what I've got available. Those are the 3 funds. Is that fair? No, because what would you call these 3 funds? Well, they're the survivors, aren't they? Because these 2 have died. They were so bad that they died. But is that, when I now go and use the 3, the survivors, is that truly reflective of the true picture of what's going on? Probably not. I would need to say, well, I haven't done so well because really I started off with 5. I've already lost 2 funds, and I'm down to 3. Okay. We've got 2 more biases. We've got the look ahead bias. Okay. Look ahead bias is I'm using information, okay, that was not available when the test was conducted. Okay, so it might well look like a very good strategy, but I'm really using data now, okay, that was not available when the test was conducted. Time period bias, okay, generally speaking, this type of bias occurs, okay, when I'm designing a test, but it's based upon a time period that the time period's wrong. Either the time period's too long or too short. For example, making the results very specific to a time period. For example, if I had to go and run samples about investment returns during the global financial crisis, well, we'll say, hold on a second, that's not really fair, is it? Because that's a specific time period related to a very specific bad time in the market. So no, it's not fully reflective. That's called time period bias. Guys, that then brings us to a conclusion of Learning Module 5. It was a fairly short one. I'm sure everybody is quite relieved at that. And a lot of the stuff you guys have all seen already, remember, in Learning Module 4. Okay, and there on page 11 and going on to page 12, we have got some summaries there for you. Guys, as per usual, I always want you guys to go back to the beginning of the particular learning module when you are finished. just do take a look again at the learning outcome statements that we always produce for you on the very front page. Make sure you are able to look at those, make sure that those make sense to you, okay, and then obviously you'll probably have a good sense then of what you've just read and learnt in the particular learning module.